Okay, this is the solution of exam 21. We start with version A. First of all, I suggest you to open SPSS alone, so you're sure to open SPSS 18 and not SPSS 17. Then you take the data and you drag it above SPSS. Okay, you open the data. The data are well known, they were present in previous exams. Draw two different graphs to describe scale variable A. So graph chart builder, the two different graphs are obviously the histogram without a normal curve and the box plot, this one. Okay, test whether the distribution of sides is uniform. Sides, you can see it easily, it's a ordinal variable with few categories, actually 3 categories. So you check whether the distribution is uniform using the chi-square test. It's here. All categories have equal probability. Run. Okay. Test whether the median of A is minus 50. Okay, in the previous point, if you display also, so if you display also the frequencies of sides, it's not a mistake, because it's actually what you want to. So if you, for example, display also the frequencies, it's not a mistake. Test whether the median of A is minus 50. So analyze the median, so it's a non-parametric test, one sample of A and not of sides. The median binomial test minus 50. Run. Display the averages of A by sides and test whether there are significant differences in the averages. So compare means the average of A by sides. Okay, well, actually they are not displayed, but only because there is a little graphical problem in SPSS. If you double click, you see that they exist. In order to check whether there are significant differences in the averages, I think it's clear that the test should be the analysis of variance, one way or another. Test whether the average of A is significantly different from the average of B. This is different. It's a test which involves two scale variables, A and B. Well, you have here various possibilities: Pearson, Spearman, Wilcoxon, and a student. But you're testing the averages, so it's clearly a parametric test, and between Pearson and student, it's student which deals with averages. So it's student test here, this one, paired sample t-test, so A and B are paired, A, B, okay. Display the histogram of C with 12 bars colored green and export it to Word file data.doc. Graph chart builder, so histogram of C, okay. You double click, you want 12 bars, apply. You can see that after you press apply, it turns to 0. It's a programming mistake, but don't worry, you have 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, color green. File, close, export to Word. So, well, there are many ways to do it. You can check export. I prefer to copy, open Word. This is Office 2007, but it works the same in 2010. File, save as. Pay attention to saving the old format. solution 21 a data dot doc. Save. Create a new date variable h, taking day from h1, month from h2, and year from h3. So very straightforward. Transform date and time wizard. Create a date time variable from variables holding parts of dates and times. So h1 for day of month, h2 for month, h3 for year. The result variable should be called h. Well, choose a format, doesn't matter. Okay. Check that it's really a date variable. Check that you have created something. Yes, 13 May 2000. Select only data from region 1. Region equal. Well, I hope that region 1 has number 1. We will check now. You never know. Region. Okay, region 1 corresponds to 1. Okay, at this point I would like to save, because you never know what is going to happen while you're doing the exam. So, data.spv. Display frequencies of variable size. Okay. Obviously, only the frequencies for the region 1 will be displayed. Select all the data. Select cases, all cases. Add a new variable with appropriate measure, missing, and value labels for question what is your age, and use Z for categories. Here, this is clearly an ordinal variable. So we go here, variable view. Let's call it age. It's numeric, you don't need digits after the comma, you need only one digit. But let's keep age. Values 1, 18, 24, add 2, 25, 34, 3, 35, 44, 4, 45 or more, 9 missing. Okay, here don't forget that to specify that 9 is missing. It's not scale, it's ordinal. The rest is okay. Save. Save. Okay, the exercise is over. You just have to close, shut down everything. And okay. Let's solve now the version B, which is very similar. Also here it's a better idea to open SPSS 18 and then load the version. On this computer SPSS 17 is not installed, but if it were, I would have opened it with SPSS 17, which is not wrong, but may cause you some problems, because the exercise is specially designed for SPSS 18. Okay, test using all the non-graphical methods you know whether variable A is normally distributed. So the non-graphical methods I know are the Kolmogorov-Smirnov test and skewness and kurtosis. So let's start with skewness and kurtosis for variable A. Options. Well, here I check only skewness and kurtosis. I could have left the other one, but in order to avoid the professor thinking that I am checking randomly things, I leave only what is necessary. See, okay, skewness -6, kurtosis 40, and the Kolmogorov-Smirnov test. Normal, okay. Is it normal? It should be no. Reject, okay. Calculate Pearson correlation between each couple of variables A, B, C, D. This is a little tricky question. Pearson correlation cannot be calculated among 4 variables. Can be calculated only between 2 variables. So between A and B, A and C, A and D, B and C, B and D, C and D. Okay, but you don't need to do it 6 times. You can do it only once in this easy way. Analyze, correlate bivariate A, B, C, D. The computer will not calculate the Pearson correlation among 4 variables, which doesn't exist, but we calculate a matrix which includes all the possible combinations of correlation. You can see correlation between A and A and B, A and C, A and D, etc., etc. Add to variable h a number of weeks corresponding to variable h2 and call the new variable h new. So h is a date. We will use the date and time wizard, if I can find it. Yes, here. So calculate with dates and times, add or subtract the duration from a date. So to variable h, we should add a number of weeks corresponding to variable h2. So h2 weeks. Addition. Okay. And call the new variable h new. Finish. Let's check, because when you do something on variables, you never know what you get. So this should be 12 weeks more. Yes, approximately it is. Now I will save this one and also save this one. You look, the name is data2. Oops. I am in the wrong directory. Data2. You don't need to press .spv, automatically it comes. Build a quadratic regression model to predict A using B. Regression model, curve estimation, only quadratic to predict A using B. Okay. Blah 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 blah. Okay, you can see, well, there is a point here. Record variable A into AG with appropriate measure and value labels as. This is a really standard grouping technique. So here you can use, for example, record into different variables if you want. Maybe also transform works, but I will use record into different variables. So A, the new variable is AG. Change all the new values. Lowest through minus 100. 1 add minus 100 through minus 50. If you have troubles understanding what happens when the value is exactly minus 100, well, they are scale variable. They are really scale variable, as you can see. They are never exactly equal to minus 100. So minus 50 through highest value 3. Okay. Well, I will put all other values. Well, missing are not required. You can see I don't require missing to be handled. So let's leave all the other values system missing. Okay. But it's not really required. Okay. Let's check the new variable. Let's assign the label. One small, 2 medium, 3 large. Okay, it's not scale, it's ordinal. Save. Draw 2 appropriate graphs for variable size considered nominal. Okay. Size is ordinal, but it has only 3 categories, so it's evidently nominal. So the first one is a bar plot, and the second one is a pie chart. Even though for nominal variable, bar plot is much better, because you see the categories in order. Okay, while in the pie chart you lose the order of the categories. Test whether there is a relation between variables size and region, and then build an appropriate graph to show both variables. Size is still considered nominal, obviously. Well, there are both nominals. An appropriate graph and the relation. The relation is clearly the key square. You have to build the cross tabs, the contingency table, however. So, size, region, statistics, key square. And you have the contingency table, which is this one, and the key square, which tells you that there is a strong difference. Now the appropriate graph, I would suggest this one, for example. This one is an appropriate graph. Okay. Maybe also this one. Size and region. Okay. Let's see. Maybe also this one may be appropriate. Put region here. Also this one may be an appropriate graph. Okay, this one I prefer b-dimensional graph rather than three-dimensional graph. Add a new variable with appropriate measure, missing, and value labels for question how many children you have, known 1, 2, 3, 4 or more. Well, a little parenthesis, this is a typical example of what you should never do in a questionnaire. How many children you have, it's a typical scale variable. So the person can simply write down the number of children, it's not an exaggerated number. However, here you offer possibilities and you group 2 with 3. Okay, there is no reason to do it, okay, but unfortunately many questionnaires insist in doing something like this. If you do something like this, unfortunately it becomes an ordinal variable. So you had a wonderful scale variable, but now, due to these strange answers, it's an ordinal variable. So you go here, let's call it children. How many children? Unfortunately, well, let's assign label 0 to none. I think it's 1 to 1, 2 to 2, 3. Well, we should assign, unfortunately we have to assign 3 to 4 or more, which is counterintuitive. Well, if you at exam assign 4 to 4 or more, it's the same. So you have chosen the intuitive solution rather than the ordered solution. 9 missing. Missing 9. It's ordinal, unfortunately. Okay, save. This one is saved. Save also. Well, I requested one graph. 2 are not necessary, so I removed the second. Okay. And now I shut down everything. Okay. Exam is over.